still got a little bit more to do. Really, the only thing that remains in dealing with areas involves finding the areas between two curves. All right, and so it's really just an extension on what we've been covering. So it's really not that bad. These numbers, I didn't write on here explicitly that this is a calculator question, but I gave you funky numbers and then a calculator display, so I figured that was more than enough information to steer you in the right direction. All right, so the question here is asking what's the total disparity in millions of dollars between the two companies from 1974 and 1988? What's the average disparity over the 14 years? All right, so the disparity is talking about the amount of area in between the two functions. All right, so basically the accumulated displacement. So what I need to do is, well, a couple of things, and the checklist here is really useful, I think. Although, when you look at a graph, hopefully it kind of makes sense why these things are the way they are. You'd want to find the point of intersection, right, because there is, in this particular case, a transition from one graph being on top of the other to the roles being reversed, all right? And it does matter which graph is physically on top, right? Because that's the one that leads off in the integral subtraction, right? So we always subtract from the dominant function the non-dominant function. So whatever's physically on top, or to the right if you're looking at it from the perspective of y, right? So that point of intersection is hugely important, right? Also, like I said, establishing which one's on top. Then we integrate the difference between the two, and then add those positive areas together to get the total area. All right, so for this question, we see that we have two not so neighborly looking functions. Obviously something that we probably don't want to do by hand. So I'm going to create this graph. The window is given to us. I'm going to reproduce it on a calculator and then find the intersection using the calculate tool. So first function's in, second function. Oh, that was weird. I haven't done that in a while. All right, so I have my two functions in. The domain is important, obviously, but this is one of those nice situations where we don't have to figure it out ourselves. So window, 0 to 14, 0 to 50. Graph that bad boy. Hope it looks the same as the picture, otherwise somebody's getting some typo bonus. Oh, it's just beautiful. Look at that. It's like I did it on the calculator and then took that image and put it in your notes. It's crazy. Astonishing. Anyway.
I see the difference, I think, with the typo.
What's that? Oh, because of this bad boy's not there?
Yeah.
I respect that. It's a different emulator. But you can take it if you want.
What?
Yeah.
No.
Why does it need to go to Flights? Do you want your phone?
I
Both are
give him,
right.
I pretty much give him for anything.
I sent him like 6 messages.
Oh, I have
Somebody in a different class, I think it was period 3, said that like there was one problem set that was talking about like exponential cooling, and it was just the algebra of it, so it definitely wasn't this class. But they were talking about that there was too many questions related to cookies, that I should mix in some like, I don't know, stroganoff or something. And I was like, okay, send it in. Typo bonus. They got 3 bonus points out of that because they found 3 problems. One became like big ZD. Oh, problem set.
Yeah. I remember that. I saw that remind.
So intersection, second trace 5. we really have 3 intersections, but if we're talking domain, we kind of have a sense that the first and the last are 0 and 50, so I'm not overly worried about that. Enter, enter, enter to get the inner ones, or the inner one. All right, so funky decimal as expected. So I'm just going to chuck that in there. 3 decimal places sufficient, although the x value will go to 4.66 and 8.441. All right, I'm just going to take a quick look at 0. Oh, actually, it does not appear that there's an intersection there, but it doesn't really matter. We do have dominance, and that's really the more important thing. I'm going to take a look at 50, see what's going on over there. Just kind of get my ducks in a row. All right, so there is a change in dominance there. All right, so it looks like they're aiming towards intersections, but they don't quite get there, and that's all right. Okay, so what I'm going to do is find the area for each interval, but I want to set up the integrals first. All right, so the integral going from 0 to about 4.66, but we're just going to use 4.66. Now, what I have to do is subtract the functions in the appropriate order. All right, so I need to designate these appropriately. The first function that was graphed was the exponential function. That's the one that started below and then ended up higher. All right, so I'm gonna highlight that. So this is my exponential function. That was, I believe, s of t. Then a of t was the other one. Capital. I undid. All right, so what's happening is that we need to subtract from the a of t function the s of t function, all right, over that first interval. So I'm going to write a of t minus s of t dt. All right, and then I'm going to add to that, going from 4.66. So the max would be 14, obviously, because it would be ridiculous otherwise. I subtract in the other order and pop it in, and hopefully come up with the right answer. Anyway.
Holy. Did you just type that all in?
Hit second enter.
Okay, I was going to say, you typed that incredibly quickly.
About 46. Nah, it was a mistake. That was no reason for it.
Is 45 enough?
Should
We have paper shortage, so I didn't want to make CCIT's do with 45.
Gotcha.
That was my best work, but apparently all of the shortcut features on Word were not working. I don't know why. All of my formatting settings weren't there.